Right now, roughly 300 miles above the coast of Brazil, there is a hazard hiding in the vacuum of space. When a satellite flies into this specific region, the energetic particles are so intense that they can flip bits in computer memory, corrupt data, or cause the spacecraft to shut down completely. The Hubble Space Telescope is entirely unable to collect astronomical data when it passes through this area. Astronauts aboard the International Space Station are forbidden from doing spacewalks here due to the severe radiation risk. This map shows the intensity of Earth's magnetic field, and those tight contour lines over South America and the Atlantic highlight a massive depression. Officially, researchers call it the South Atlantic Anomaly. Aerospace engineers often call it the Bermuda Triangle of space. Every day, billions of dollars of critical infrastructure are forced to fly blindly through this invisible, highly irradiated dead zone. To understand why spacecraft are frying, we have to look at how Earth protects itself. Our planet generates a powerful magnetic field that catches dangerous charged particles from the sun. These trapped particles form the Van Allen belts, two donut-shaped rings of radiation suspended high above the equator. But over the South Atlantic, the magnetic field is unusually weak, and the inner radiation belt sags downward, reaching as close as 120 miles from the surface. And the problem is compounding. Data from the European Space Agency reveals that since 2014, this anomaly has grown by nearly half the size of continental Europe. It is actively splitting into separate lobes and aggressively migrating toward the west. A vital section of our planetary shield is breaking down rapidly, creating a localized hazard for anything we put into orbit. Figuring out why it's happening requires a massive leap in scale. The source of the anomaly isn't found in the vacuum of space. It is buried nearly 2,000 miles directly beneath our feet. Down here, the Earth's outer core is a sprawling liquid ocean of superheated iron and nickel. This molten metal is in constant motion. Hot liquid rises from the depths, cools near the mantle, and sinks back down. Combine this turbulent convection with the daily rotation of the Earth, and you create a massive internal generator called the geodynamo. As the liquid metal twists and flows, it produces the electrical currents that project our magnetic field out into space. When this immense rhythmic engine flows smoothly, the magnetic shield around our planet remains strong and uniform. But the geology of the Earth isn't perfectly uniform. Deep beneath the African continent lies a massive, incredibly hot formation of dense rock. Because the African continent lacks subducting tectonic plates, which normally push cooler surface rock down into the depths, this particular patch of the mantle stays heavily insulated and extremely hot. When the rising molten iron of the outer core slams into this scorching thermal roadblock, it can't cool down efficiently. The normal, smooth convection cycle breaks down, and the fluid dynamics become chaotic. This turbulence creates what geophysicists call a reversed flux patch. The disrupted flow of liquid iron actually forces local magnetic field lines to fold and loop backward, pointing straight down into the core instead of projecting outward. That localized underground magnetic reversal directly cancels out the strength of the main magnetic field directly above it. Without that upward magnetic pressure, the radiation belts sink closer to the atmosphere. The dead zone, threatening billions of dollars in orbit, is simply the surface shadow of a geological traffic jam raging deep inside the Earth. Because this magnetic dent is actively moving and growing, there is a popular fear that it signals an imminent flip of the Earth's magnetic poles, a scenario that would temporarily strip away our global radiation shielding entirely. But the geological record tells a different story. To read that history, geologists look at paleoposits like cave stalagmites. As water drips and these limestone structures slowly grow over centuries, they lock in a physical record of the Earth's magnetic field. This animated graph overlays stalagmite concentric rings against historical magnetic strength, showing clear, repeating dips tied to this exact region. These mineral rings prove the anomaly isn't a modern glitch. It's appeared and faded for at least 11 million years. It's an ancient, deeply ingrained geological pattern, operating on a schedule far older than humanity. Researchers identified a clear cycle. The anomaly is born in the turbulent mantle underneath Africa. Over roughly 250 years, it drifts westward to South America, where cooler mantle causes it to dissipate. Then a new anomaly forms in Africa, repeating the cycle. We are attempting to fly highly sensitive microchips through an environment dictated by millions of years of shifting rock and magma. To safely maintain our presence in space, we have to look past the stars. We have to engineer our technology to withstand the ancient, unstoppable heartbeat of the Earth itself.